Electricity is essential to our daily lives, but like everything else around us, the cost of electricity continues to rise. Hot water can make up to 60% of the average household's electricity consumption, and most probably the best place to start to reduce the effect of these ever-increasing prices. I recently met with Leroux Smit from Hydronic Engineering to talk about the most common options available to reduce your electricity consumption and still enjoy a hot shower. Welcome, Leroux.
Thank you for having me here. Appreciate it.
Leroux, would you mind just giving us a little bit of a brief background as to who you are and your company and what you offer as a service?
Well, first of all, my name is Leroux Smit. I'm a mechanical engineer by profession. I sort of got stuck in the renewable energy at my years when I did my practical part of my studies, and actually never left the industry. I started my own company about 2 years ago, Hydronic Engineering, but I've been in the industry for the last 16, 17 years, since 2005, so that makes about 17 years. Yeah, it's my company, Hydronic Engineering. We focus on basically PV installation, design, supply, install, repair, and service of photovoltaic installations, hot water plant rooms. That includes hot water tanks, underfloor heating, pellet boilers, heat pumps, solar water heating, the whole spectrum basically.
Yes.
So in a nutshell, that's what I offer.
So just in terms of the topic of discussion today, domestic hot water solutions, would you mind just giving us an overview of what is available in South Africa today to the consumer, and perhaps give us the rundown in terms of pros and cons, perhaps, in terms of to help anyone make a decision as to what it would be the best solution for them.
So as a commercial solution, or as something that you can sell with a minimal input from the client side, there's basically 3 options available, or 3-4 options. I mean, you get the normal solution. It's a hot water tank with electrical element. That is very easy, very little maintenance. It's only the anode and the geyser basically, and you change the element and the thermostat when they fail. It's most likely one of the most expensive ways to heat water, but it's no-nonsense, simple. You can stick the geyser in a corner somewhere and let it do its thing. Then you've got the option for gas. What's nice about gas, you've got no storage vessel. It's like an inline, water comes through, gets heated, goes to the application. There's basically no heat losses, no standing losses. Obviously there's a heat loss between the gas geyser and the point of consumption, but it's very simple, inline, very simple solution. What's nice about it, you can do it on the remote area where you don't need electricity. You can get these igniters that work with batteries, or you can have a pilot flame. It's nearly the same cost to heat water. I mean, I've worked it out roughly. Sorry, just to get back to electricity, I did a couple of calculations just to give an idea of what it costs. I based all my costs on basically 150 litre geyser, and from cold water coming in to heated temperature, you need around about 7.8 kilowatt hours of energy. That's the same as the units on your prepaid meter.
Yes.
So, or any electrical meter. That my calculations exclude standing losses. Standing losses does differ from geyser to geyser. It depends on where the geyser is installed, outside, in the roof, in a cupboard. I take all those variables out, but just to heat the water. And obviously reheating the water, it's the same amount of energy, or percentage wise it will be the same. So it's just to give an idea of the initial heating cost.
Yeah.
With the 150 litre geyser, you're gonna need about 7.8 kilowatt hours to heat it. So I base my cost on $2.60 per kilowatt hour. Obviously that depends also where you stay, what you pay. but that would roughly work out to 20 Rand and 30 cents to heat a geyser.
Yes.
So electrical element, at least 20 Rands to heat the geyser once per day. Obviously, as you use water, the water needs to be reheated, the geyser also cools down, but initial heating cost, 20 Rand, 30 cents. Then let's go to the gas next. Cool. If you, on a gas geyser, I worked out that you would need roughly 0.68 kilograms of gas to heat the same amount of water. That would work out to roughly 19 Rand 40 to heat 150 liters of water, and that's worked out at about 28 Rand per kilogram for the gas price. That obviously also differs on where you buy. What's nice about this, as I said, you need no electricity input. It's instantaneous and works in load shedding. And but it's also very similar to element cost. It's fairly high to heat your water, and obviously your gas needs to be installed by a licensed person, needs to be serviced yearly. But basically all solutions need to be looked at least once a year by a professional to make sure everything is still intact, but what seldom happens. In any case, we can look at the other solutions. Heat pump.
Yeah.
All right. Heat pump is a very interesting thing. It's you got to find an alternative heating supply if you want to go green to fit your application.
Yeah.
There's the remaining ones. The remaining ones are solar and heat pump, and also the gas. You got to remember the gas has got a flume or exhaust gas that you got to discharge somewhere. You can't fit it anywhere. You got to have an area that's sort of dedicated, and maybe exhaust that goes to the outside, or where you can direct the heat to. That's something you just got to keep in mind. And obviously, you've got the diminishing oxygen in the room that you need fresh air into that room for the gas. You'll consume the oxygen, so just got to remember that. With a heat pump, obviously, what's nice about a heat pump, you can stick it outside on a wall. It looks like an aircon unit basically. It's not very different in operation. You just need to be within 5 to 8 meters, preferably from your geyser, so you can circulate your water between the geyser and the heat pump.
Yes.
And what's nice about the heat pump, depending on the brand, make, technology used, you get between a COP, which is your coefficient of performance. That is basically your ratio of how effective the heat pump is. You would normally range between, let's say, 2.5 and 4. That's roughly what you're looking at on the market. One thing with a heat pump, the output or the performance of the heat pump is greatly affected by the surrounding temperatures, your environmental outside temperatures.
The ambient temperature,
In cold weathers, let's say you're looking at about 8 to 10 degrees, your heat pump drop about 40% in performance, roughly.
Yeah.
It's from output. So if you had a 5 kilowatt heat pump, it only puts out 3 kilowatts, and then your COP is not as high as it is.
Yes.
It goes to 1.5, 1.8 easily when it's cold weather.
Yes.
But you do get brands that's especially the European markets, they focus because they've got a lot of cold weather there. Some heat pumps operate better at colder temperatures than others, depending on the gas technology used inside and so forth, type of compressors and so forth. But to get back to the heat pump, we're working on a COP of 3.2, which is fairly mainstream. You can expect that on a good 20-25 degrees Celsius day. You need about 2.4 kilowatt hours to heat that same geyser. From 7.8 to the element, it's now 2.4. And that works out to 6.6 Rand at 34 cents at the same 2 Rand 60 per kilowatt hour. So it's a significant saving on your water heating. That's at least in the region of like a 67% saving on your water heating bill, which makes out, as you said, a large part of your home's consumption. And obviously, you also need yearly service. Your heat pump has got fins at the back that needs to be cleaned out. And depending on your water quality, sometimes if you live in an area with high lime scale or calcium, you would need to descale pump because you get just a layer build up inside the heat pump because it's hot metals inside. It's same as a kettle, you get calcium depositing on your hot metals. So you just put a what they call a light descaling solution or a vinegar or something of the sort just to dilute the lime scale. You get back to the bare metal because that's your lime scale acts as a barrier between the hot gas and the water.
Yes.
And the heat can't be transferred from the gas to the water. So the less material there is in between, the more effective the heat pump will be. So that's something. Some heat pumps need to be done every 3 to 5 years only. You know, there's not a lot. If the water quality is good, it's seldom an issue.
Yes.
But yeah, it's just something you need to look at. And also something with heat pumps, you got to remember is they normally have an inline strainer to protect the heat from solids moving from your tank.
Yes.
Believe me, if you ever empty out a burst geyser, it's nasty what's inside there. So you sometimes get from your municipal side, you get sediment coming in, burst pipes. There's soil, sand, a lot of stuff moving into your geyser that you're not aware of.
Yeah.
Because the heat pump starts at the bottom, you need to just prevent the heat exchanger from clogging up. So you need to have that also cleaned out once a year, or if you had a severe breakage in outside from the municipal side, a lot of the times there's muck coming in, and you might need to have that cleaned.
Okay.
But it's cheap running costs, and it's fairly easy because you can, with a flat, let's say you live in a multi-story building, you can't always put solar on the top. It's not your roof, or it's too, yeah. So a heat pump you can put outside on the side of a building, put it on a balcony. There's ways and means to do it.
Yes.
And also, if you've got a small enough heat pump or a big enough inverter, you can always run your heat pump from the inverter and run it with solar power. Then basically you don't pay for your hot water. It's for free. So you can rather have a slightly smaller heat pump, let it run for longer periods, and you don't put up so much of your capacity of your inverter. Yeah. So that's something that I would prefer as the best solution. You know, then your water heating is absolutely free. And the last option, well, the last two options, you've got solar water heating, which is you get the two options. You can either do like a solar thermal panel. Which you've got literally, it's the old school solar panel. You've got copper pipes soldered onto aluminium or a copper sheet that bakes hot in the sun, and you circulate your hot water through there. That is by far your cheapest way of heating water, because in a thermosiphon configuration, you've got absolutely no electrical input. When the sun shines, it heats up. As easy as that. The only issue there is there's no stop. So if you go away for a weekend, you come back on a Sunday afternoon, summer, your whole system cooked there for days on end, your hot water could be sitting at 70, 80, 90 degrees Celsius, and that's enough to take the skin off your body, to get bad burns. So you need to fit what they call an anti-scalding valve on the outlet or a hot water mixer. It's just something to regulate the outgoing temperature. It blends the hot water with cold water and just ensures you've got safe temperatures going out to the taps.
Which means there might be a lot of water loss, I assume.
Yes, if you, I mean, in areas where it's hot and you do get systems that will get to a stagnation point where the water will actually be hot enough for the heat pump or for the tank to open the discharge valve, the TP valve, and you have to let cold water come in, and you discharge that hot water hopefully to a safe place, either onto a roof or into down the side of a building or just to the outside. But I've seen gutters melt, plastic gutters. They lose their shape. They're not made for hot water, you know. So that is just something to look at. And then the other option, obviously the solar system, it's the same. You've got hot metals. You need to have your panel descaled once a year, or, you know, once every less 3 years at least, because of the possible scaling that can happen in areas with the high calcium content. Then you also have you've got PV panels. You normally fit about 1.5 kilowatt of PV panels, and you've got just a specialized element where you've got a controller that just converts that energy to heat the water.
Yes.
The nice thing, we always joke about it, wires don't leak water. You know, so with heat pumps and solar water heating, there's a possibility of pipe leaks. Pipes need to be insulated. You can't run pipes sometimes just in a corner. Obviously, the insulated pipes are quite thick in diameter, so they're more difficult to hide. With the PV elements, you can just run little wire down the wall to the element. You know, it's much easier to do it, but obviously you need roof space to do that. It's not fit for every application. You do need to take each situation on its merit, and there's not a cookie cutter solution. You've got to look what's available. The one thing with PV heating that I don't like, you would often use prime roof space, and if the client wants to do inverter and batteries and solar panels, you can seldom incorporate that into the rest of your system.
Yes.
It's a different type of panel. You can't put it on the same string, and so my preference would be inverter, batteries, solar, like a proper system, and you would run a heat pump. It's your cheapest cost, and just to run it off your system. And if the water is heated, you can use that electricity for something else.
Yes.
With solar water heating, with normal solar water heating, there's no power generated. It's just hot water. That roof space is only for hot water. You can't do anything else with it. With PV water heating, that PV power can only go to the element and nowhere else. So yes, it works well, but you're limited to the usability of the excess power. I'm a solar guy. I grew up in the solar water heating industry. I've done some of the largest solar water heating applications. I love it, but in winter time, you do need a backup. Unfortunately, especially here in the Western Cape, our sun is about 40% compared to summertime. So you do need additional input, and it's either coming from alternative source like element or heat pump or gas. The sun is not enough to power a solar water heating system or a solar PV, your PV element, heaters. You need element input, and it's then your 2 to 4 kilowatt input into your geyser. It's quite a big load.
Yes.
That if you have to supply your own power, it's quite a chunk of energy that you need to supply.
Okay. Just if anyone wants to get in contact with you, Leroux, what would your contact details be?
Yes, I'm on WhatsApp, Telegram, SMS. Anybody can contact me. My number is 071-732-0206. Or you can email me on leroux@hydronic.co.za, and Hydronic being HYDRONIC.co.za.
Awesome. Just to get back, just to make sure that everybody knows, in terms of if anyone needs any hot water application solutions, Leroux, as well as PV installations, Leroux will be able to assist you with both those inquiries. Leroux, once again, thank you very much for joining me and chatting about our different options. And hopefully we'll have you on again and maybe talk about some other solutions like PV installations. Thank you very much for joining us.
100%. It's a pleasure, and thank you for having me. It's an honor.